Hello everyone, today I'm going to show you how to do the rain effects. I made a character crawling on the ground, so I made it rain. Let's see how it looks. This is just flipbook. You can see we have in the foreground we have the big raindrops and on the character you can see the drops drawing through the character. This is another one with motion blur on. Actually, it's quite easy, just the POP swap. Let's see the thing. I have the character here, a character, then convert, subdivide, then switch, then output the VDB, output same time, output the geometry. You can see it's not moving. It's not moving, then start moving. Let's see the ground. I have a grid, the mountain, color, add this character, color, attribute transfer. I use the solver to transfer the color on. See? Then attribute blur, blur the color bit, the attribute wrangle, make py equal minus equal cd the y, multiply the offset you can see. Yeah, a little bit downward, a little bit downward, then delete the color, file cache this, then I have the bound. This ground is huge, I just want part of them, so instead of the bound, I delete outside the bounds, just keep inside the bounds. See, use this volume sample the surface value volume, then clean all the attributes, keep the CD, extrude the volume, then I output this as a geo, output this as a volume VDB collider. So for the rain effects, I have 100 preroll, so it starts from 9,900. Let's see, I have a grid here, up, I have a grid, then go POP network, POP network, POP network, then point flow set, points generating, grid false. It looks like this. Yeah, but you can see this stepping issue. You have to figure out how to make it right. It's quite easy. Just go here, go here, go here, go the source. We go negative and back. Let's check. See, it's all done. So we have the rain. Then we need a static object. Merge them together. This our character. Sorry, static object character. Merge here. So it's R always left inside. We go our character out to it's moving object, so we need check the deform geometry. We use the volume sample, then go here, character of the VDB. Let's check how it looks. This how it looks. Let's go. See the ring clad with this geometry. We can set UP force, give some wind, give some noise, also POP drag downward, port 1. We can POPQ because we don't want the points to downwards. Let's use the bounding. Let's check the bounding. Don't check this. Check the bounding. Enable the bounding. Okay, it worked. Okay, we have this bounding. The rain drops. So POP behalf collection behalf. Then we create a group, hit group. You can see when the particle hits, it turns red. Also, we need POP wrinkle. We set up the bounce here. at POU and E equal 1. Okay, now we have the POP group. Then we group this as main, as main. Okay, we don't need the red point, so we can delete die. So we delete, just keep the main row, main ring, POP stream. We go this head group. For row, no need, just the POP replicate. This our main row, main ring, main. This our let's check splash, 5 splash or 6 splash. Then we go here point noise, a little bit noise, or maybe not. We can add here one. Let's move here. Let's see how it looks. See, we have a small particle here bouncing. Let's add a POP group. Pro group. Group name is splash. Maybe it died too fast. Let's see. To be honest, it's not easy to see. We can kill the box here. Let's visual big points. Oh, this group we caught wrong name. Now it should be good. See, we have the red points bounce and okay. Let's go back check our setup. First, we have this. Then we have the POP stream, hit group, and POP replicate, shape, add velocity not so high, POP color, POP wrinkle, bounce as well, in group. Let's check how this tool looks. Just check this. See the main ring, and there's a bouncing ring. Okay, then we have another one, POP stream, POP replicated, just replicated 1 point, then use the zip, then POP color, POP rank bounce equal 0, we don't want to bounce, we POP behave, then we need the point just to stick there, let's check, just stick there. We should able see the point just stick there. It's quite hard to tell, but the points stick there. We paste these points, then we create another round sprung, then go duplicate one as well. But this life we make longer. This like a running slide, then bounce 0 as well. We use the build properties set the clean 100 is make the points push them together. Then POP collision behavior we group around. Then we preserve this group and slide with the surface. Then POP interaction, this positive point 2 means make the points attract each other, reduce velocity. Then let's see how it looks. These 4 elements together. Yeah, it, it should be able to see some points here. See, let's check now. See some points flow along the surface. See, then now we cache out this. See, cache out this. Then we blast. This is the main because we have the groups. We have the groups main, running, run, sprung. Then we have the main, as plus. We have the run. The run looks like this. Point running along the character. Then we set sphere, physical, copy, then this physical, and also orient equals the velocity, so the direction of the droplets facing the velocity direction. And this similar one is for the smaller parts here, and also this for the running point. We use VDB from particles, then convert VDB, then attribute transfer. See like this, running through the geometry. Then we cut inside, these characters inside the part, and put them together, clean this our result. Let's see. So this is our rain effects. For rain, we need the wet map. Rain render, we need a wet map. So I set up a wet map here. We for this character. For this character, we add the wet attribute equal 0 because it's not wet yet. Then we input the rain, delete attribute, then give the white attribute equal 1. We transfer this rain wet attribute to the character wet. So we use solver. First, previous frame, previous frame, and input. We transfer this input. We use previous frame the wet attribute transfer to this geometry. Then we use attribute VP get the rain wet PC open. We PC open the rain every point. We get the wet attribute. Every rain they have the wet attribute. We get that. Then we use PC font. If we found some rain near the character body, it will equal some value. And compare this. If greater than 1, greater than 0 is getting the first input result. It's 0, so it's wet. It's 0. If this PC found something, it get second one, so it's get this wet value. We bind import our wet, then add them together to bind wet out. It's quite simple. Then I add blur, a wet attribute blur, and get CD wet. Let's see how it looks. See, it looks like this. Carrot getting wet. Let's flip book. With the rain.